So let's practice. It says line TP is tangent to circle O at T. The radius of circle O is 8 millimeters. TP is 6 millimeters long. Find the length of OP. So my suggestion is that you pause the video and then I'll start it back, give it a try, and then start it back up and see how you did. All right, so I started you off with one that was baby cakes. And hopefully the one piece that I wanted you to see was this perpendicular, which made this a right triangle. And you saw your 6, 8, 10 pattern. And I know you did, so you got OP as 10. So that one's pretty easy. It's a nice baby cakes one. Let's go ahead and look at the next one together. Pause it if you need to write it down. But I'm going to work through it. The problem says a circle, or rather pause as you need to, because I probably will not give enough time for you to write. A circle with a radius of 8 centimeters is externally tangent to a circle with a radius of 18 centimeters. Find the length of a common external tangent. So when we look at this problem, they gave me everything that was in black. That was what the picture looked like. So I had my two circles, I had this radius QA, and I had this radius PB, and I had segment AB. So that's everything that they gave me. Now to do these problems, when you have this picture and we have externally tangent circles and we're asked to find something about them, then what we need to do comes in 5 basic steps. The first thing that we're going to do is, if it's not there, we're going to draw the line of centers. So that is segment PQ. So connect your centers. Step 2, draw the radii to points of tangency. Again, in this particular picture, they happen to give it to us. So I didn't need to draw it in, but sometimes you will need to. Sometimes they won't give you anything but the words, and you'll need to draw your own picture. This blue step is the one that's a little bit tricky. I'll read it first. It says, from the center of the smaller circle, draw a line parallel to the common tangent. We're going to draw in this line from P to segment AQ. And if you want to give it a letter, you can. Change my color here to blue. So I'll just call it, apparently I'm going to call it N. So if we call this point N, PN is one that we drew intentionally so that it was parallel to AB. And since we know that this angle A is a right angle, and we know that angle B is a right angle, right? Tangent to a radius makes a right angle, and we got parallel lines. Now we have a rectangle. We have a rectangle, and we also have down here in this corner a right triangle. So we connected line of centers, and then we constructed a rectangle. Now we need to use our Pythagorean theorem and our rectangle rules, and we'll be able to solve this. So, let's see. Let's work in orange. A circle with a radius of 8 is externally tangent to a circle with a radius of 18. So if I call PB, since it's my smaller, it has a radius of 8. And I know that AQ, that whole thing, has a length of 18. But I just constructed a rectangle, so this side needs to be 8. And NQ actually is 10. So we'll see a lot of times that these problems are not drawn to scale. But now what? And this is one of those tricky spots. When we have an external tangent, right, here's my point of tangency, it's on the line of centers, then we also know that this QT has a radius length of 10, and TP is also a radius. It has a length of 8, making PQ, this whole segment, a length of 26. And now I can find the length of segment NP, which is the same as the length of segment AB. I would do 10 squared plus NP squared is equal to 26 squared. Let's see. NP squared is equal to, I don't know 26 squared off the top of my head. How to find it. 26 times 26, 676. Oops, I forgot to subtract 100. 576. So that the square root of 576 should be 24. Which means that AB also has a length of 24. So let's recap all of our steps because there's a lot of writing on this picture now. We're going to read through our problem, and the key phrase was the fact that our two circles were externally tangent, so that they touch each other and they're outside one another. They touch at one point and they're outside. They gave us the radius of each circle, and they asked us to find the length of a common external tangent. So my line AB is tangent to each of the circles, and it's outside or not between them. After we have our picture, we made sure we had a radius to each point of tangency, that we had a line of centers, and then we constructed a rectangle that was parallel to the line of tangency. And once we had that picture that had a rectangle and a right triangle, we started filling in numbers in order to use the Pythagorean theorem and our rectangle rules to solve. So our homework assignment for tonight is worksheet 10.4, number 1. You should have picked it up on your way in. Tuesday we'll have a review, Wednesday we'll finish a review, and Thursday is our quiz 10.1 to 10.4. I will see you on Tuesday.